Aashto T248, reducing samples of aggregate to testing size, covers the reduction of large samples of both coarse and fine aggregate to the appropriate testing size while maintaining the representative nature of the samples. First, let's examine the procedure for reducing a sample of fine aggregate. For an aggregate to be categorized as fine, 100% of the material must pass a 3/8-inch sieve. For samples that are saturated surface dry or drier, use method A, the mechanical splitter. If your sample is wetter than saturated surface dry, use method B, quartering, or method C, miniature stockpile. If the moisture condition of your sample is not apparent, determine its condition by performing the fragile hand cast. Just squeeze a handful of material. If it retains its shape, assume that it is wetter than saturated surface dry. If you desire to use method A, you must first dry wet samples to the SSD condition or drier, but when doing so, be sure that your temperatures do not exceed those specified in the test you will perform on the sample. Method A employs the use of a mechanical splitter having an even number of chutes, not less than 12, which discharge alternately to each side of the splitter. The chutes may be no wider than 3/4 of an inch, but must be at least 50% larger than the largest particles in the sample. The hopper shall have a width that is equal to or slightly less than the overall width of the chute assembly. The receptacles must catch the entire discharge from the chutes. Now, let's look at the procedure. Introduce the sample such as to allow free flowing through the chutes into the receptacles below. Approximately equal amounts should flow through each chute. Obtaining a tare weight of your receptacles provides an easy way to check approximate sample masses during the reduction process. Reintroduce the material from one receptacle as many times as necessary to attain the specified mass for the intended test. Record the mass of the test sample and any other pertinent information. The remaining material may be saved and further reduced for other tests. Method B employs the use of a hard, clean, level surface or a canvas blanket. It's always a good idea to brush the surface before you begin. Place the sample on a hard, clean, level surface that will not contaminate the sample. Brush or wipe clean all utensils that will be used during the procedure. To ensure the material is thoroughly mixed, the entire sample must be turned over a minimum of 3 times. With the final turning, create a conical pile. Flatten the pile to uniform thickness and diameter. Be careful to push straight down and not slide the material around. The intent is to maintain the material composition of each quarter as if separators had been inserted into the conical pile. The diameter of the resulting pile should be from 4 to 8 times its thickness. Divide the pile into 4 equal parts using a straight-edged tool. Remove diagonally opposite quarters, making sure to remove all fines. Continue mixing and quartering in this manner until you have a sample of the desired size. Used for damp fine aggregates only, Method C is procedurally identical to Method B, except that the conical pile is not required to be flattened, and a small sample thief or a small scoop or spoon is used to obtain the desired sample. From the resulting miniature stockpile, obtain a sample for each test by taking a minimum of 5 increments from randomly selected locations. Now, we'll reduce a sample of coarse aggregate. Coarse aggregate samples may be reduced using Method A, mechanical splitter, or Method B, quartering. Method C is not suitable for aggregates containing coarse particles. The riffle splitter, used in reducing samples of coarse aggregate, must have an equal number of chutes, but no fewer than 8. Each chute must be approximately 50% larger than the largest particle in the sample. We're using a splitter that's set up for aggregates with a maximum particle size up to approximately 1 3/8 inches. The configuration is basically the same as the fine aggregate splitter: a hopper above the chute assembly and 2 catch pans. The procedure is exactly the same as with fine aggregate. Uniformly distribute the sample in the hopper and regulate the rate to allow a free flow of material through the chutes to the catch pans below. Reintroduce the material from one receptacle as many times as necessary to attain the specified mass for the intended test. When using method B, the procedure is the same for either coarse or fine aggregate. It will be more difficult to flatten a conical pile of aggregate containing coarse particles. Extra care must be taken to maintain the material composition of each quarter as much as possible. Remember, the purpose of this standard is to reduce a field sample to testing size while maintaining the representative nature of the sample. Method A is preferred when applicable. It is important to collect all fines and to avoid any loss or contamination of material. For more details on the most recent specifications, consult the latest Aashto publication, which may be ordered by calling 202-624-5800 or online at transportation.org.